Trig Equations 2, we're going to solve trig equations. Now with these, there's some things that we may have to do before we can actually start solving them. That involves algebra. One thing is we want to make sure that everything is equal to 0, and we may have to factor in some cases. Some cases we'll just use identities, and I have a list of those that we may look at, we may need to use. So whenever we need to use those, I will use those. And then other times we may have to just square both sides, which is another algebraic manipulation. So let's solve these. We're going to solve these on an interval from 0 to 2 pi. So start the first question. First question, if you take a good look at it, it looks like it's in quadratic form. Now if I let x be sine theta, what we actually end up having is it's 2x squared minus x minus 1 equals 0. Now the preferred way to solve these is by factoring. And if you can factor, that will make your life a whole lot easier. If not, you may have to use the quadratic formula. And I will write that down. I prefer not to use this, so I'm not going to. You may have to do that if it's quadratic in nature. But I'm going to factor. And when I factor, since it's already equal to 0, I like to do the full method backwards. And when I factor, I think what times what is 2x squared, and that's 2x and x. What times what is 1? 1 and 1. Now I need a negative 1 in the middle. So what that means is I need a positive. I get a 2 from the outers and I get a 1 from the inners. So that means that I need this to be a negative and this to be a positive, so that when I fold it out and check it, I get the correct answer. Now what I want to do, I'm going to go ahead and put the sine theta back in. I'm not actually solving for x, I'm solving for theta. So for now, I'm using sine theta. Now I will come back and maybe show you a different way to do this with your graphing calculator if you really don't have a clue what to do. So now what I want to do is set each one of these equal to 0. And I want to solve for, first off, sine theta. So that means I'm going to subtract 1 and divide by 2. And I end up with sine theta equals negative 1/2. And then I'm going to add 1. And we get sine theta equals a positive 1. Now remember, we're solving only on the interval from 0 to 2 pi. So what I want to do, I want to think what theta is. Theta is all the angles in this interval such that sine theta equals negative 1/2. And what are those angles? Well, sine of 30 degrees is 1/2. So that means that I need to be in the third and fourth quadrants. So what this actually is, it's 30-degree angles in quadrant 3 and quadrant 4. And what those are, in the third quadrant, it's 180 plus 30, which is 210 degrees. And then the fourth quadrant is 360 minus 30, which is 330 degrees. Now I'll come back and convert those into radians. But for now, let's go over here. So we need theta such that I can use inverse sine if I want to, where inverse sine is positive 1, because this is a positive 1. Or where does sine equal 1? And the only place where that's actually true is at 90 degrees. And I already know what that one is pretty quickly. That's pi halves. Now on these down here, we need to find what the values are. And once again, I'm going to show you how to do that with your graphing calculator. All I'm going to do is take 210 and divide out the 180 degrees because I'm using pi equals 180. Then I'm going to hit math, enter, enter, and that's 7 pi 6. And then for 330, I do the exact same thing. And hit math, enter, enter. And I get 11 pi 6. And I can also use my unit circle. 210 is 7 pi 6, 330 is 11 pi 6, and then where the sign is 1 is at pi halves. So that means that my solution is pi halves, 7 pi 6, and I forgot my pi over here, but as long as you put it in somewhere, you're fine. And that's the answer for that one. So, using trig. Now, if you don't remember how to factor, watch this. What you can do is take out your calculator, go to y equals, and this is just a shortcut way, it's a backwards way. Is take 2x squared minus x minus 1 and graph it. Now, where it's crossing the x-axis is where x equals 0. Or in this case, where sine theta is going to equal 0. Remember, I said x is sine theta. There's two ways of doing this. You can use second trace and then the 0 feature. But I want to use the intersect feature. In order to do that, remember my graph is intersecting the x-axis. The x-axis is the same as y equals 0. So I'm going to hit enter, and y equals 0, and then graph it. And it is graphing or recognizing that y equals 0 is the x-axis. So now when I go to second trace and hit intersect, which is 5, I'm going to move it over to the left, somewhere close to that x-intercept, and hit enter 3 times. And you'll see negative 0.5, which is the same as negative 1/2. I'm going to hit second trace 5, which is intersect again. And this time, I'm going to go over and hit enter 3 times. And we get x equals 1. 1. So that's a backwards way to find that using the graph on your calculator. Now let's solve this one. Cosine 2 theta equals cosine theta. Now cosine 2 theta I don't like. So what that means is I'm going to go to my trig formulas and see what cosine 2 theta equals. So I have a choice. I can use cosine squared minus sine squared, or 1 minus 2 sine squared, or 2 cosine squared minus 1. Since this right side is cosine, I'm going to use 2 cosine squared minus 1. Because I don't want to have more than one trig function whenever I can. Or I can eliminate one of them. In other words, I don't want cosine and sine in the same equation. It's like having x and y in the same equation. Or x and w. So now, cosine 2 theta is 2 cosine squared minus 1, and then that equals the right side, which is cosine theta. What I'm going to do now, since it looks like it's quadratic, I'm going to subtract cosine theta from both sides to make it equal to 0. And now I have 2 cosine squared theta minus cosine theta minus 1. So once again, this looks like it's quadratic in nature, so that's the same if I let x equals cosine theta, that is, then that's going to be the same as 2x squared minus x minus 1 equals 0, which I've already factored this once, or shown you on a calculator how to use it. You can also find it, or use the quadratic formula, or complete the square. So we have 2x and x minus 1 plus 1, and I end up with x. I've already done the work above, so let me just repeat my steps without having to actually repeat them all. I'm just going to put in 2 cosine theta plus 1, because everywhere I have an x, I now have cosine theta, and then cosine theta minus 1 equals 0. Once again, I've already solved this for sine theta. It's the exact same steps, so I'm going to go straight to cosine theta equals negative 1, and then cosine theta equals positive 1. So So now I want to think, where does cosine equals -1 for what angles? That's the same as a 60-degree angle, because cosine of 60 is 1/2. But since it's negative, that means I'm in the second and the third quadrants. So cosine 60 in the second quadrant is 120 degrees, and in the third quadrant it's 240 degrees. I'm going to come over here. Where does theta equal 1? Well, since I'm only looking at the interval, once again, from 0 to 2 pi, 0 is included, 2 pi is not. I know that cosine of 0 is 1, 0 degrees, which is the same as 0 radians. Is there any place else? If you need to, look at your unit circle. Where's x equal to 1? That's a -1, but there's nowhere else. And once again, I need to find 120 degrees. I like to do this in my head first before I look at the unit circle, just to verify. I know that 60 degrees is the same as pi thirds, 1 pi thirds, 2 pi thirds, 3 pi thirds is pi, 4 pi thirds. Now let's verify 120 and 240. 120 is 2 pi thirds and 240 is 4 pi thirds. You wondering how I did that in my head? I knew that 6 goes to 100, or 30 goes to 186 times, so I knew it was pi 6, but I'm actually looking at a 60-degree angle, because 120 is 60 degrees away from 180. So I'm looking at a 60-degree angle, which is pi thirds. I know that's 1 pi thirds, and that's 2 pi thirds, and 3 pi thirds is back to pi. So I knew 2 pi thirds is the same as 120. 3 pi thirds is pi, and then 4 pi thirds is back to 240. That's how I do this in my head, in case you're wondering. So the solution is 0, 2 pi thirds, and 4 pi thirds. When I was taught back in the day, I wasn't allowed to use a unit circle, and I didn't have a calculator to find these values for me. So I had to memorize them. That's the way I prefer to do them. Now let's look at this one. I see I have cotangent squared and cosecant. I have two different trig functions, and I'd really like to make both of these be the same trig function. So let's look at cotangent squared and see if we can find anything in our list of formulas that will help us out. So cotangent squared is what I'm looking for. And there's nothing that jumps out, but I do see sine squared plus cosine squared. So let's see what we can do with that. Sine squared theta plus cosine squared theta equals 1. And this is one that you really should memorize, or have memorized by now. And I need a cotangent squared, which is cosine over sine squared. Cosine squared over sine squared. So if I divide that by sine squared, I'll have my cotangent squared, but what I do to 1, I have to do to all. So let's divide each one of these by sine squared. So sine, anything divided by itself is 1. Cosine squared divided by sine squared is, it's not tangent, that's sine over cosine. It's cotangent squared theta equals 1 over sine squared is cosecant squared theta. So what that means is I want cotangent squared if I subtract 1 from both sides. And by making these videos, what I'm actually doing is showing you what my thought process is. You can see exactly and hear what I'm thinking as I do this, which is a good thing about the videos. So this is what I'm thinking. I didn't see anything on my list of formulas that I had that had a cotangent squared in it, but I knew I had sine squared and cosine squared equals 1, that I could manipulate it to have a cotangent squared just by dividing everything by sine squared. And once I do that, I'm going to substitute cotangent squared is cosecant squared theta minus 1, and then minus cosecant x minus 1 equals 0. And I have cosecant squared theta is the only cosecant squared term I have. Then I'm going to put minus cosecant Well, it's not theta, it's actually x. X, theta, doesn't make a difference. Either one is fine. X, and then minus 1 is minus 2 equals 0. It looks like another one of these factoring problems. So that's where I'm just going to go straight to that factorization using cosecant. So y times what is cosecant squared? Well, cosecant x times cosecant x. Y times y is 2, and that gives us a negative 1. And that's the only thing you're thinking. Anytime there's nothing in front of the first term, these are actually a whole lot easier to factor. Y times y is negative 2. That equals a negative 1 when you add them together. How about a negative 2 plus 1? So what that now means is, I'm going to set each one of these equal to 0. It's called the zero factor property in case you're wondering. I'm going to solve for cosecant x in both of them. This one I'm going to add 2. This one I'm going to subtract 1. Now I want to solve for x. Now cosecant is the same as 1 over sine. So here's what I'm thinking in my head. This is just my thoughts. 1 over sine. And I know that sine of 30 is equal to 1/2. And if I flip that over, I have a 1 over sine equals 2 over 1. Well, 1 over sine is cosecant. So I'm looking at 30-degree angles. And since this is positive, and sine is a y value, I mean, this is how I think. Sine is a y value, where y is positive. Well, y's are positive in the first and second quadrant. So that means I need the 30-degree angle in the first quadrant, and then the 30-degree angle in the second quadrant is 180 minus 30, which is 150 degrees. And the other two quadrants are negative signs. Now let's come over here. Negative 1. So what I'm thinking now is cosecant same as 1 over sine. So where does sine equals negative 1? Because negative 1 over 1 is the same as 1 over negative 1. So I'm just thinking about negative 1. And the only place where it's a negative is at 270 degrees, which I know as 3 pi halves. Now 30 degrees is the same as, well, here's how I think to do this. 30 goes into 180 6 times. So I need pi 6, that's from 180 degrees. 180 degrees is pi. Pi is the same as 6 pi 6. So if you take a pi 6 away from 6 pi 6, you get 5 pi 6. Now here's how you can use a unit circle. Cosecant x equals 2. I still have to think 1 over sine. Sine of 30 is 2. I don't really have to though. Watch this. Whereas cosecant 2, well, it's the same as the reciprocal of 1/2. So it's at pi 6, and it's a positive 1/2, and 5 pi 6. So if you have the unit circle, this becomes a whole lot easier. Where does sine equal negative 1? Then the only place is 3 pi halves. And so I have all my values, all my solutions. Pi 6, 5 pi 6, 3 pi halves. If you are fortunate or allowed to use the unit circle, it does make your life a whole lot easier. I'm just showing you in case you don't get to, without using a calculator or anything else. Now let's look at this example. This one is different than the other ones. Now, what I want to do is I need to be able to manipulate this. So, one thing I can do immediately is go ahead and divide both sides by 3. That may or may not be a good thing, but what it does do is it gets rid of one of those numbers that I may or may not need. And then it just makes it a little bit easier to see. If you notice, I see a sine, cosine. What else do I know has sine and cosine in it? Tangent or cotangent. But I like to use tangent better. Tangent is the same as sine over cosine. So what that means I want to do is divide both sides by cosine theta. And sine over cosine is tangent theta. Well, look at that. I now have an equation I can solve, and I can solve it in my head. How do we do that? I know that since tangent is sine over cosine, and I need a square root of 3 somewhere, so I know that square root of 3. How do I get that? Well, let's just think about it. I'm doing it in my head now. I have the square root of sine of 30, or tangent of 30. Sine of 30 is 1/2 over square root of 3 over 2. That's not going to work. Sine of 45 definitely isn't going to work. Square root of 3 over 2 over 1 over 2. Those 2's cancel, leaving the square root of 3. Well, when is sine of square root of 3 over 2? When it's a 60-degree angle. So this is a 60-degree angle that we're looking at. It's all about, do you know how to do your algebra? And I'll clean that up a little bit for you so you can see exactly what I did. I want something that has a square root of 3 on top. And the values I know, square root of 3 over 2 is one of them, over 1/2. And then if I do outers over inners, or multiply by the reciprocal, multiply by 2, it's probably the best way to do it now. I get my square root of 3. And sine of what angle gives us the square root of 3 over 2, because that's what I was looking at first, square root of 3 over 2. Well, that's the sine of 60. Since tangent is positive, and it's positive in what quadrants? The first quadrant, and also the third quadrant. So that means that theta is going to be 60 degrees in the first quadrant, and then in the third quadrant it will be 180 plus 60, 240 degrees. And once again, in radians, 60 goes in 183 times, so it's going to be pi thirds. 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds. The main thing is recognizing that if you are going to use a unit circle, not the calculator whatsoever, is that square root of 3 over 2 and 1 over 2 is what you're going to be using. So the y value is square root of 3 over 2. Y value is. And it's positive, so it's pi thirds. And I need the other one where the y is square root of 3 over 2 in the third quadrant, because the negative divided by negative was a positive. So 4 pi thirds and pi thirds, and that's what I have. Now let's look at this one. This one is a little different. When I have a plain old sine, plain old cosine, and add or subtract it together, there's really not much I can do as far as looking at identities or anything like that. I can't use tangent because that's division. I really can't use anything on my formula sheet. So there is an algebra trick you have to do. We're going to square both sides, which means raise both sides to the second power. And then one reason is most of my formulas, if not all of them, have squares in them. A lot of them do anyway, the ones I tend to use. So let's fold this out. So that's the same as sine theta plus cosine theta times sine theta plus cosine theta again. And 0 squared is 0, so it still stays at 0. Let's multiply it out. Sine times sine is sine squared theta. Sine times cosine is sine cosine. I'm just doing the full method. I did those two first and then those two. Now when I take cosine times sine, I get sine cosine again, which means there's two of those. And then cosine times cosine is cosine squared theta equals 0. And now, if I rearrange these terms, sine squared plus cosine squared theta is equal to 1, which means that this and this becomes 1. I'll just write down what I'm thinking in here. So I have 1 plus 2 sine theta cosine theta equals 0. 2 sine theta cosine theta. I've seen that before because it's right down here. 2 sine theta cosine theta, which is sine 2 theta. So I have 1 plus sine 2 theta equals 0. Now I want to subtract 1, and we get sine 2 theta equals negative 1. So where does sine equal negative 1? And what angles? Let's think about it. Sine is the y value. It's only at 270 degrees. But since we're dealing with 2 theta, that will change things. So what it means is that 2 theta is actually going to be 270 degrees. This is just my thoughts over here. I can also use my unit circle. Negative 1, 270 degrees. And since we're doing sine has a period of 2 pi. I have to consider all the way around 2 pi k, but I don't want to use 2 pi. I'm using degrees for now. 2 pi same as 360 degrees. And k, because we may have to go around more than once. So when I divide everything by 2, I get pi equals 135 degrees. Plus 180 degrees k. So I have to look at all possibilities. When that time I deal with 2 pi, especially 2 pi, or anything that changes the period, because if you remember, there's a formula that says the period is equal to 2 pi divided by the omega, and this is your omega. It affects the period. So I have to always consider all the possibilities then for this new period. And that new period is 180 degrees, because when I divide 2 pi by 2, pi is the same as 180 degrees. So what that means is that one angle is 135 degrees. And then if I take 135 and add 180 degrees, what do we get? 315 degrees. If I add 180 more, that's way too big. It's outside of 2 pi. So all I need to do now is find what does 135 degrees equal. Let's just go to the unit circle. And that's 3 pi fourths. And 315 is 7 pi fourths. So that means our solutions are 3 pi fourths and 7 pi fourths. Done. Now there is another approach to solving this problem. One thing you can do is subtract cosine theta from both sides. So we end up with sine theta equals negative cosine theta. And then what you can do is divide both sides by not the negative cosine theta, but rather just cosine theta. Because I want tangent on one side. That's what I'm actually doing. Sine over cosine is tangent theta. And then these cosine thetas cancel, leaving the negative, but anything divided by itself is 1. So now we're thinking, where does theta equal a negative 1? And that's a bad looking theta. Where does theta equal negative 1? Well, if you look at our unit circle, we know that tangent is y over x. So anytime we have the same thing divided by itself, we have a 1. We're looking for a negative 1, so that's going to put us in the second quadrant and in the fourth quadrant. So it's at 3 pi fourths and 7 pi fourths once again. Three pi fourths, 7 pi fourths, 3 pi fourths, 7 pi fourths. Done.